Ready? Okay, this is for the Apology of Chemistry, Module 11. We're talking about the chemistry of solutions. First, we're going to talk about the states that matter can be in. We talked about this last week. We said that you can have matter as a solid and as a liquid and as a gas. And remember, when you have it as a solid, the molecules are very tightly packed. Okay, so in order for anything to get in there, there has to be such a strong attraction that the solvent can get between those solute molecules. With the liquid, the molecules are spread farther apart, so it's easier to get between. And with the gas, the solvent has to be able to pull the solute closer. So let's talk about some examples of that. First of all, let's say you have a solute, and that's what you're dissolving in, like sugar dissolved into tea. In that situation, your sugar is your solute, your tea is your solvent, and the solution is the solute and the solvent together. Okay, that's the solution. So when you have the solid, the liquid, and the gas state that you're looking at, and those molecules are pretty tightly packed, it's going to be harder for things to get in. So how much dissolves in that solution is going to depend on three things. It's going to depend on what the solute and solvent are. And we talked about tea being an example. Tea with sugar in it. Okay, in that case the solute is the sugar and the solvent is the tea. You could also have water with salt dissolved in it. And when you come back next week, we're going to talk about how much salt a glass of water can hold. If you have 100 grams of water and you begin to dissolve salt in it, you're going to find at some point, even if you're stirring and you continue to add the salt, it's going to start to precipitate out on the bottom. You'll start to see those salt crystals will no longer go into solution. But that's going to behave differently from if you have a solution with alcohol and salt. And we're going to look at that next week when you come to class. We're going to look at how the difference of the solvent, even though the solute changes, the solvent is different, the water and the alcohol. And so the amount of solute that it can change will change with the identity, what it's made up of. The amount that the solution can hold also changes with the temperature, and you guys have seen this happen. If you go, we talked about this last week, if you go to a restaurant and you get cold iced tea and you try to add sugar to it, it doesn't work very well. The sugar starts to precipitate out pretty fast. But if you're making your tea at home and you get it nice and hot and then you add the sugar, it's going to take more sugar. More sugar will dissolve into it. So for a solid, the amount that will hold increases with the temperature. And that's what happens with your tea and your sugar. With a liquid, if you have it, it's not going to be affected by temperature. And with a gas, it's going to decrease. The amount that it is able to dissolve will decrease as the temperature increases. The third thing that's going to affect how well things dissolve or how much solute goes into solution is the pressure. Now, if you increase the pressure with a solid and a liquid, it's not going to make a difference at all because they're already fairly tightly packed. But if you increase the pressure with a gas, you're pushing those molecules closer together. So if you increase the pressure with a gas, it's going to behave more like a solid or liquid, and it's going to increase the solubility. And so you'll have more ability for things to dissolve into that. Okay, so we're going to pause here and we'll be talking about some new concepts.